Wait for 2-3 more minutes. No issues.
Ma'am, you start, ma'am. They'll join, they'll watch that on YouTube, ma'am. It's already time.
Ma'am, you are on mute.
Sorry. Thank you, ma'am. Fine. So I'll start with today's session, and I'll cover today the chi-square test, right? So we'll share my screen first. My screen is visible?
Yes, ma'am.
Fine. Thank you, ma'am. So, starting with the today's agenda, till now we have understood that few things like what is variable, what are the types. We understood this thing that what are the measurement scales. Also, we have explored the interface of SPSS. We have tried to understand the concept of normality and reliability. Now it's time to dive into the statistics and use the statistical test, right? So when I talk about the statistical test, we can divide the all kind of statistical test into the two broad category named as parametric test and non-parametric test, right? So what is parametric test? That I'll discuss tomorrow. Today I'll talk about the non-parametric test because today is a day off where I'm talking about the chi-square test, right? Fine. So firstly, we need to understand the concept of non-parametric test, and then I'll start discussing the chi-square test. So when I say non-parametric test, so meaning is that I'll start the session from the term population and sample. So anyone who can tell me what do you understand by term population in terms of statistics?
Population means the overall entire people person.
Okay, fine. Anyone else?
Ma'am, it's a group of things it's a group of people from whom we derive a sample to be tested.
Okay, fine. Okay, good. Anyone else?
Universe of the study.
Okay, fine. So according to me, when I say population, because this is in terms of any research or any study, right? We are not talking about a normal population, the population of country, right? So when we say population, population is the entire set of people or objects which are pertaining to our research problem, right? So whatever research problem or study we are carrying on, we are dealing with, accordingly, the population size or population will be decided, right? So many a time it happens, population size is very large, right? So when population size is large, it is not possible, feasible for our researcher or analyst to collect the data from each and every unit of the population. In such cases, what we do, we are drawing a representative sample from the population known as sample. And using that, we are trying to conduct a study, right? Now comes two terms, parameters and statistics. So parameter is what? Parameters are generally known as the characteristics of the population. The statistic is nothing but are the characteristics of the sample. So when I say I'm having a suppose the age data of a particular set of people, so we know this thing. I can calculate average, standardization, etc. That way we would be in a position to comment anything. So these things are what? These things are known as characteristics, right? So we can say when we are talking about the population characteristics, we can say we can represent them by the mean, median, standard deviation, proportion, etc. Likewise, when we talk about the sample characteristics, we can say we can again use the sample mean, sample standard deviation, sample variance, sample proportion, etc. So mean in all, in total or in all, if I want to say, I want to conclude this, I can say whenever we are talking about the characteristics, whether it is of population or sample, we can call it as a parameter and statistic. For population, we are using parameter term. For sample, we are using statistic term, right? So when you talk about the non-parametric tests, so in itself, it is now explaining you, these are the tests which are not depending upon the parameters of population, right? Chi-square test is one of them. It is not using any characteristics of the population. It is not using any parameter of the population, right? So we can say chi-square is known as the non-parametric test. So in other way around, if I want to define non-parametric test, I can say all the statistical tests which are not considering the distribution of the data, especially the normal distribution of the data, those tests are known as the or comes under the category of non-parametric tests, right? I hope I'm clear on this.
Yes, ma'am. Just repeat, ma'am, that last.
Ma'am, please once again explain, please.
From where, ma'am? Can you tell me?
Non-parametric test, the definition, ma'am.
Okay. I said non-parametric tests are the tests, or this category includes the tests which are not considering the distribution, especially the normal distribution of the data, right? So when you are not bothering about the normal distribution of the data, or your data is not following the normal distribution, generally we are going for the non-parametric tests, right? Is it fine now?
Ma'am, you told about chi-square is not something like that you told, ma'am. That was the line we asked for repeating.
Chi-square is a non-parametric test. I think I said this.
It
is not
it's more than the population or something you were telling, ma'am.
Sorry, repeat again.
Chi-square, if it's more than the population or something like that, you said, ma'am.
I said this thing when, as I said, according to the name, that is non-parametric, right? So
Yes,
we
ma'am.
can say it is not considering the parameters of the population. If you have seen the formula of chi-square test, you know this thing, the formula is based on the frequencies. It is not at all talking about the mean, standard deviation, etc. So that way we can say it is not considering the parameters of the population. That is why we can keep this test under the category of non-parametric test.
Okay, ma'am. Thank you, ma'am.
Yeah. Is it fine? Shall I go ahead?
Yes, ma'am.
Thank you.
Yes, ma'am.
Yeah. So now question comes where to use non-parametric test. Although I have just included this thing, but again I'm repeating. First thing is that when you are having the categorical data, that is your data should be of nominal scale or ordinal scale order, right? Means if you are measuring your data on nominal scale or ordinal scale. Say for example, I want to see the habits. I want to compare the habits of male and female, maybe reading habits of male and female. So reading habits meaning is maybe I'm asking, are you regularly reading? Person is saying yes or no. I am having the gender of those persons. I can categorize them in the male and female category. So here you can understand I'm having the two variables. Out of these two, first one is the reading habit. That is, I'm asking, are you regularly reading, right? Second one is the gender of the person. So both are the nominal skill variable here. So if I am having the nominal skill variable or ordinal skill variable, in such cases, we cannot go for the parametric test. We should go for the non-parametric test, right? Apart from that, one more thing comes, that is sample sizes of these study groups are unequal. Means whatever the groups you are taking, say for example, male group, female group. So the sample size is generally unequal. In that case also we can go for the non-parametric test, because chi-square can deal with that, right? Because chi-square is a test which is generally requiring the equal sizes of the group, but for unequal sizes also we can go with the test, right? Next thing is, when your data is not following the normal distribution, right? Means suppose you are intended to perform a parametric test, say for example ANOVA, maybe t-test or something like. But if you are going with the assumptions and you are checking the assumptions using your data, and if your data is not going through or not following the assumptions of that particular test, in that case it is suggested to go for the non-parametric test, because usually in the parametric test assumptions like normality is must. Usually for some of these statistical tests which are parametric, generally we need to also see the homogeneity of variances, that is equal variances we are looking for. So if your data is violating such kind of assumptions, even in that case also we can go for the non-parametric tests, right? So in all, if I want to conclude, I can say when I'm having the categorical data, that is nominal scale or ordinal scale data, and when my data is not following the assumptions of any parametric test, in that case we are having the substitute test available in the non-parametric test category, which we can opt for, right? And that way you can work ahead. Till here I am clear?
Yes, ma'am.
Fine, thank you, ma'am. Now coming to the agenda of the day, that is chi-square test. So now chi-square test is also known as Pearson's chi-square test because it is given by Carl Pearson. So that is why it is also known as Pearson's chi-square test. As I said, it is a non-parametric test because it is distribution free. We are not looking for the normal distribution of the data. And usually when we are interested to find the association between the categorical variable, we will go for the chi-square test, right? Apart from that, when I said chi-square test, one more thing is there, that is when you want to compare the observed and the expected frequencies, in that case we are going for the chi-square test, right? So that means we can say this thing whether the significant difference is there in the frequencies or not. If you want to test this, in that case we can go for the chi-square test. Now there is a division, or we can see the types of chi-square test, right? So I'll take it chi-square test, types of chi-square test in the upcoming slide. But here I think this slide is talking about the things which you need to consider while deciding that you will go for the chi-square test or not, right? So this says the chi-square test only tests whether two individual variables or independent, are independent in the binary format or not. This is what you are intended to find or test using the chi-square test. Means not always two variable, although I have written here two individual variables, but as I'll go for the types of chi-square test, so it is not like for both of the chi-square tests you need to have two variables, right? But if suppose you're talking about you are having the two variables available and the format of those variables is the binary format, that is dichotomous format, that means you are having only two categories, yes, no, right, wrong, correct, incorrect kind of, male, female kind of. So in that case, you can generally go for the chi-square test. Both the variables should be of the same nature here, right? Then chi-square also requires that researchers has to use numerical value, should not use the numerical values. Numerical values meaning is here little different, right? Usually when I say the weight of a person, so weight of a person will be some number, that is a numeric value. But here the numerical value in case of chi-square test meaning is that it is frequency or count. So chi-square data will always be having the count of frequency. So again I'm repeating my example. I just said we want to compare the reading habits of the male and female. So it is quite obvious. I can ask, are you reading? So it means I can count how many of the people are saying yes, how many of the people are saying no. So this way we will be having the count of the yes category, no category according to the gender, that is male and female. So this way we will be having the frequencies, right? So usually chi-square test is deals with the frequencies. Now coming to the types of chi-square test. I hope till here I was clear to everyone.
Yes, ma'am.
Yes, ma'am.
Yeah. Now talking about the types of chi-square test. As I said, Generally, there are two types of chi-square test. The first one is the goodness of fit. Goodness of fit chi-square test is also known as the one-way chi-square test. One-way chi-square test meaning is what? Here we will be having only the single categorical data or single categorical variable, right? So in case of single categorical variable, usually we know this thing when we talk about the hypothesis, we need to have two variables, right? But when I'm having the single variable available, how I can formulate a hypothesis and how I can check it? Because chi-square test is one of the statistical tests which is helping us to test the hypothesis. And as I said, for making your hypothesis, generally you need to have two variables, right? So in that case, if I'm having a single variable available, so how I can formulate my hypothesis? So hypothesis will be like, you will compare the frequencies. Frequencies of what? Whatever is the observed frequencies, you will take that, and then what is your expectation that you can take. So you will compare observed and expected frequencies. So that way you can say there is no significant difference in the observed and expected values. Values meaning is frequencies, right? So I think I forgot. I need to keep it here frequency only, right? So that way we can say we are comparing the expected and the observed frequencies using the chi-square goodness of fit test. So even having a single variable, if I'm having a count, I can treat that count as an observed count, and whatever is my expectation according to the category, that will be the expected count, and I can make a comparison in these two counts, and this way I can test or formulate a hypothesis and test it. So we can say frequency distribution is uniform across all the categories. This is your null hypothesis. Other way around, null hypothesis can be there is no significant difference between observed and expected frequencies. So let's take now some examples to understand chi-square test, goodness of it chi-square test in a better manner. Suppose I am having here a first example which says red, green, blue, and yellow candies are equal in number or not, right? So here I am having a variable single, which is color variable, and in which I am having the 5 color category: red, green, blue. Sorry, 4: red, green, blue, and yellow. So according to maybe suppose I'm asking the preferences of the colors of the people. So I have given 4 choices: red, green, blue, and yellow. We can collect the preferences which people is liking which color. So that way I will be having a count that these number of people are liking red and likewise. So that way this will be the observed frequency. Expected will be generally, maybe we can assume, suppose I'm having a survey of 100 people. So I'm expecting in each category there will be 25 people, right? So that will be the expected count. So this way you can understand what will be the meaning of expected count. Second example says local car colors follow the global distribution, right? So maybe we can observe now that usually we can see we are watching or finding that there are more white or black colors cars are running on the roads and all, right? So that way we can check the distribution of the colors, car colors, and we can check whether the distribution is global or not, or following the global distribution or not. Next one, equal number of customers visit shop each day. So whatever is the count coming per day footfall, I can note down, and I'm expecting whatever it is. So I can write down my expectations, and that way we can make a comparison. So it is known as, again, one of the examples of goodness of fit. And in all 3 examples, you can find we will be having only a single variable, right? Now comes the second type of chi-square test, which is known as the Pearson's chi-square test of association or independence of attributes, right? So I think I will write here one more thing, that is independence of attributes. Fine. So there are 2 names of second type of chi-square test. First one is the test of association. Second one is the independence of attributes, right? Means whether the attributes are independent or whether they are having any association, right? So in case of second type of chi-square test, we are requiring 2 categorical data or 2 categorical variable. Both the variables we are treating as an independent variables, right? So we want to see whether the two categorical variables are independent of each other or whether they are having any association between them. So for example, suppose we want to see gender performance on the driving test. Means gender is one variable. The result of the driving will be your second variable. Whether the person has qualified that driving test or not will be the outcome, right? So maybe I can say the person has passed the driving test or has not passed the driving test. So male, female, and pass and fail will be the two categories in both the cases. So this will, if we want to find the association between them, we can go for the chi-square test of association, right? So here,
Ma'am, I
Yeah.
have one question. In chi-square test, which you are explaining, in independent variable and dependent variable, both should be categorical.
usually chi-square test is a non-parametric test, ma'am. It is not talking about the dependent variable. Two
Okay,
variables are treated as an independent variable only.
Okay, ma'am, if the outcome also should be in categorical.
Outcome means suppose here
Means
I
in the
given you
previous example, we were assessing that the
Okay.
gender, we are having
the
two genders.
performance on driving test. So gender
Yes.
performance means gender is one variable, right?
Yes, ma'am.
So whosoever person is going for the driving test, whether he will be a male or he will be a female, right?
Correct, ma'am.
And
Yes,
that
ma'am.
outcome will be whether he will pass that test or he will fail that test, right?
Okay, ma'am.
So that here you can say I'm having two independent variables. First one is gender, second one is driving test, right? Now I want to find whether there is any association between them or not. If association is there, that means one variable is depending on other. Otherwise, we can say both variables are independent of each other.
Okay, ma'am. I was just having a confusion. If outcome may be 3, then what will be 2? Then also we will
No
apply
problem
the
with
chi-square.
that. Yeah.
Okay, okay, okay. Thank you.
Number of categories are not violating this rule. Only you need to have two categorical variables. Variables
Okay.
can be two, categories can be any number. It is not restricted.
Okay, ma'am. Thank you, ma'am.
Okay, so I think I read this, maybe not. So I can say there is a, I can say the null hypothesis will be there is no relationship between the categorical variables, right? So if you know that the value of one variable, it does not help you to predict the value of another variable. Why I'm saying this? Because further, when we talk about the correlation and regression, there this type of things come, right? Because in case of regression, we want to see we want to measure the dependency. Here, that is the ma'am, whatever you ask. Here, you can understand this thing. I cannot say I am knowing the gender of a person, so his driving test result will be what, whether he will fail or whether he will pass. I cannot comment with this. Or vice versa, if I'm knowing this, that result is pass, so that person's gender is male or female, I cannot go for the prediction of such kind of thing. So this kind of things we cannot do using the categorical data. Getting my point?
Yes, ma'am.
Yes, ma'am.
So now, why I'm showing you questions, because till yet means so far whatever understanding I have drawn with the research, I understood this thing. When you talk about the research, you are generally raising certain number of questions, right? When you are doing the literature review, you are raising certain number of questions. So questions are becoming the base of your objectives and the hypothesis, right? So that is why with this particular intention, I am just showing that suppose your question is, you want to measure this thing, whether there is any association between the ownership of car and the family type, right? Or maybe you can frame your question like whether ownership of car is related to family type, or maybe you can say whether the ownership of car is dependent on family type. One and the same thing. All questions are generally giving you the same meaning, right? But formulation or writing of the question can be little different, but meaning are same, right? So meaning is that we are raising this question. So when you will look at this particular question, it is very clear to us. If I'm looking for the association between the ownership of car and the family type, I can say this thing, that I'm having the two categorical variable, ownership of car, and second one is the family type, right? So if I want to find the relationship between the two categorical variable, I'll go for the chi-square test. If this is my question, so in that case, what will be my hypothesis? So my hypothesis can be there is no association between ownership of car and family type. Or you can write your hypothesis like ownership of car is not related to family type. Or you can say ownership of car is independent of family type. Clear?
Yes, ma'am.
Clear, ma'am. Yes, ma'am.
Now, coming to, I think this is again a repetition. I forgot to delete this, but it's fine. We can say this thing that when you talk about the chi-square test, you can have the nominal or ordinal scale data. You will be having the frequencies. So when you want to find the relationship between the two categorical variable, you are going for chi-square test of association. Now comes to the important part, that is assumptions of Pearson's chi-square test. You can see the reference from where we have taken this these assumptions, right? The first one says individual observations should be independent of each other. That means from the one person you will collect data only once, so you would be in a position to maintain assumption number 1. Second says expected cell frequencies should not be too small. That is, expected cell count should not be less than 5 in more than 20% cells, right? Means if you are having the expected frequencies, you are having the expected counts available with you, you need to check in at least means we can say if it is less than 5 in 20% or less than 20% cells, it is fine for you. But if this percent is more than 20, that is 25, 30, 35 something, so that means if 30-35% cells are having expected count less than 5, that means this is a violation of the chi-square test, right? So 20% below 20% or 20% is okay expected count value, but if expected count goes above to this, means the percent goes above to this, that means there is a problem or the assumption is violated by the data. So expected count should not be very small, right? Then talking about a term named as contingency table or cross tabulation, right? So cross tabulation and contingency table is what? It is a two-way kind of table, or it's a two-way arrangement of your data where you will take one variable in the row, other variable in the column, and according to the categories of both the variables, we will write down the frequencies. So this arrangement is known as contingency table or cross tabulation. So with the example in the upcoming slide, I'm explaining you the contingency table. So there you can see, I hope the table slide is visible, right?
Yes.
Here you can see this is nothing but this is the contingency table. So as I told you, when you're having the two categorical variables, one variable you will take in a row, one variable you will take in a column. So here you can see column variable is the car ownership, row variable is the family type. So in the car ownership, I am having two categories, yes and no. In the family type, I am having the two categories, joint family and nuclear family. So you can see joint family, if a person belonging to the joint family and he is owning a car, how many people are there? 34 out of 100. Joint family belonging to the joint family and having no car. There is a person, how many persons there are? 66 out of 100. Nuclear family having car, 55. Nuclear family not having car, 45. That way you can see we are having the row count and column count, right? So this particular arrangement of the data is known as cross tabulation or contingency table. I hope it is clear.
Yes, ma'am.
Yeah. Now, although there is no meaning to show you formula as we are using a software, but I always show because somewhere it will help us being an academician to understand the concepts, right? So you can see chi-square test calculations are based on the formula which says chi-square is equals to summation of O minus E square divided by E. In some books, in place of O, we can find FO. In place of E, we can find FE. One in the same thing. Meaning is what? It is observed and expected frequency, right? So you can see if this is the formula, and the formula you can find in whether it is numerator or denominator, it is totally about the frequencies, right? Nowhere we are finding the mean, standard deviation, variance, etc. So this is also indicating that chi-square is a non-parametric test, right? Now comes observed frequencies will always be with us, or always we will be having, because we will collect the data, that is your observed data, right? Question comes how to get the expected frequencies. So as I discussed, two kind of chi-square test, named as goodness of fit and the test of association. In both the cases, the calculation of chi-square test will be different. Although in the software, we do not need to calculate this. Software will give you by your own. But still, I'll let you know the first way of getting the chi-square value, the E value, that is expected frequency value, is this. This first the first E formula will be used in case of goodness of fit, right? So what this formula says is, this says total observations divided by total of, it is not total observation, it is total of observations. Just a minute. It is total of observations. Fine. Yeah. So it is total of observations divided by number of observations. It means it is like an average of the observations is known as the expected frequency. Whereas in case of the second kind of chi-square test, that is the test of association, the E, that is expected frequencies, can be calculated as row total into column total divided by grand total, right? For example, if suppose I want to calculate the expected frequency for joint and yes category. For the joint and yes category, observed count is 34. So for this observed count, what is the expected frequency? If I want to get it, I need to get the row total. So this is first row element. So we will get the first row total. First column element, we will get the first column total. So meaning is row total into column total. That is 100 multiplied by 89 divided by grand total, that is 200, will give you the expected frequency. Likewise, for the 66, 55 and 45 also we can calculate the expected frequencies. Although again I'm repeating, you do not need to bother as we are using SPSS, and SPSS will give you very easily. Now I think I'm skipping this slide. This is the manual calculations of chi-square test table. So I'm skipping this. And if you are going for the manual calculations, you will always be, means you will be having the value of the chi-square test. You will be having the chi-square statistic. So you need to compare that value with the table value. And this is that table. So using this table, you can get the chi-square table value, and you can make a comparison in the your calculated value and in the standard value of the chi-square. And that way you can decide whether you are accepting or rejecting the null hypothesis.
Ma'am, excuse me, ma'am. Can you move that name coming there, ma'am? 1 second. That stop sharing is coming in that slide, ma'am. Can you move that, ma'am?
This one?
Yes, yes, ma'am. Thank you, ma'am. Thank you, ma'am.
Yeah. So now, how to perform chi-square test, we will see now. Fine. So example and everything we will be having in the sheet which I provided to you, expecting you to open the sheet. Firstly, we will go with the goodness of fit. So I have provided you the candy colors kind of sheet. The sheet is named as candy colors. So expecting you to open it. Opened, everyone? Shall I go ahead?
Yes, ma'am.
Fine. Okay. So firstly, I need to make you clear about the data structure or the arrangement of the data when you are using the SPSS, right? So you can see I have given you 3-column data where you can find the column number 1 is color 1, then color and the frequencies. There is no difference in the data. Both are the similar thing. Means the column number 1 is what? This is 25 times I have written 1. You can go and see till 25 you will get 1. Right? Then 2 starts. So 2 will come 20 times. So next 20 times means till 45 you will get the 2. And then 3 will start. So meaning is that this is the frequency distribution form of the data and this is only the indivisible data I have mentioned. Is it clear?
Yes, ma'am.
Yes, ma'am.
Why I have shown you this? Because you need to understand this thing. If your data will be in the first form like this, indivisible data you will be having. So in that case, there is a different process of performing chi-square test. If your data will be in the frequency distribution form, in that case, the process is little different. Is it clear?
Yes, ma'am.
Yes, ma'am.
Okay, so firstly, I'll take the data when I'm having the indivisible data available with me. In that case, we'll see how we will perform chi-square test. So for that, firstly, anyone who will attempt to make a hypothesis for this, these are the 5 colors. You can go and see in the variable view. It is defined there. I'll use this and you can find. These are the colors. 1 is for blue, 2 is for pink, 3 is for green, 4 is for brown, 5 is for yellow. Right? Expecting you to tell me what will be my null hypothesis here in case of this kind of data. I'm having a single data because we're talking about the goodness of it. Anyone? Fine. No issues. If you wish, you can note down. If you people are making your notes, you can note down. We can say this thing. There is no significant difference in the observed and expected frequency count of candy colors. There is no significant difference in the observed and expected count of candy colors. Fine.
Yes, ma'am.
Excuse me, ma'am, please repeat.
There is no significant difference in the expected and observed count of candy colors. So let's take, suppose this is a data, because I am very used to of playing Candy Colors, Candy Crush game, right? I very frequently I play whenever I get time, although it is little tough to get time nowadays, but still I like to play Candy Crush, right? So suppose a company of Candy Crush game, they want to understand which new candy color they need to introduce in that game, right? So maybe they are doing a survey. So that way you can see this is the data of that only. How many of people want to introduce a red color, maybe brown, pink, etc. So that way this is the data available with us. Company wants to know whether the distribution is uniform or not for the colors which the company is asking. Is it clear?
Yes, ma'am.
Yes, ma'am.
So we want to see the color distribution is uniform here or not. So now we'll go to perform the chi-square test. As I talked about the assumptions in the slide. The first assumption was related to that you should collect data once only from one person. So I think this is maintained in this data. We can assume this. Second is you need to see the expected count. So that will be coming in the output of the chi-square test. So that assumption we will check there, right? Now go to the analyze, then non-parametric tests, legacy dialogues, and the chi-square. Repeating, go to the analyze, select non-parametric tests, then select legacy dialogues, and then select chi-square. Done.
Yes.
So shall I click on this?
Yes, ma'am.
Now we will go with the first variable, that is color one. Shift the variable using the arrow into the test variable list box. Done.
Yes, ma'am.
Now, after this, although nothing you need to do, but still I am explaining with this dialog box. Here you can see at the bottom side, lower left side, if you will see, there is a section called expected range, right? This is telling you expected range. First option is get from the data. Second one is use specified range. Means for the expected count, expected value of your data, if you want to define that expected value in what range, if you want to define this, so you can use the second option, that is use specified range. You can define here and you can give the lower and the upper value. So that means SPSS will take the expected value in that range only, right? That is the one thing. But I think this is generally suggested. We should go according to the data. So I'll go with the by default option. Second says expected values. If suppose you want to define your expected value by your own, so you can go to the values option. But if you will go with the first option, that is all categories equal, meaning is that for all, suppose I'm having the 5 colors, right? And the total of this means this is the data of the 100 people. So if I'm saying 5, so 100 divided by 5 is 20. That means expected count will be 20, 20, 20, 20 for all the categories. This is the meaning of the by default option. But if suppose you wish to define your expected values by your own, you can go with this and you can enter the values. And once you will enter the value, add will be activated and you can add on. Only precaution you need to make is that whatever values you are entering, the sum of all those values should not exceed 100. It should be exactly 100 because we are having the survey of 100 people. So this is the thing you need to maintain. Other than that, nothing you need to do. You need to click on the OK only. I hope it is clear.
Yes, ma'am.
Fine. Click on OK. Okay, so output is generated. I hope you also got the output. Shall I explain you what is the meaning of this?
Yes, ma'am.
Fine. You can see the first table is telling you these are the colors which we have entered. This is the observed frequency. That is 25 people are liking blue. 20 wants to introduce a candy in the pink color, then green 20, brown 15, yellow 20. As I told you, we went with the by default option, so that is why the expected count is coming 20 for all the 5 categories, right? Residual is nothing but it is a difference of observed and the expected count. So that is your residual value. At the second table, you can find we are getting the chi-square value, which is 2.5. Degrees of freedom is 4. It is n minus 1. So it is 5 categories, 5 minus 1, which is 4. Asymptotic significant value is 0.645. Means this is your significant value. This is your p value. You can compare this p value with your level of significance. Usually, according to my domain, we are generally testing the hypothesis at 5%. So that you need to decide what is your level of significance, and that way you can compare. So suppose let's take a 5% as a level of significance. That is 5% meaning is 0.05. So you can compare this 0.645 with 0.05. It is clearly visible that 0.645 is greater than 0.05. So thumb rule I told you yesterday itself, that is if the p-value is greater than level of significance, in that case you should hold your null hypothesis. You cannot reject it, right? So in our case, null hypothesis was there is no significant difference in expected and observed count of candy colors. So we will go with this. Means it is not telling you the difference is significant. If difference is significant, then company needs to bother. But in that case, company can say, company can launch a new color candy of any of the color. It is no problem. Is it clear?
Yes,
Yes,
ma'am.
Fine. Now, I'll tell you the second ways, right? So we'll go to the data. Yeah, you can see this was the data. So when your data is given along with the frequencies, in that case, before performing the chi-square test, you need to weigh all your categories with the frequencies. So how you will weigh this? For weighing this, you need to go to the data tab. Go to the data tab. At the bottom, I hope you can find weight cases. Click on that. Then you can see at the right side of this dialog box, by default, it is saying do not weight cases. By default, it is not weighing our cases, but we want. So what we do, we will select the second option first, and we'll select the frequency. Here you can see it is asking for the frequency variable. So the frequencies, wherever you have stored, whatever name you have given, that thing you need to supply in this frequency variable box. And then you can click on OK. I hope it is clear. Shall I?
Yes, ma'am.
Fine. So once you are clicking on OK, you can come back and you can see at the right side bottom. I think you can also observe in my case, it is written weight on. Visible, I hope, right?
Yes,
Yeah.
ma'am.
In your case also, if you are performing, you can see the same thing. Now, my all categories are weighed by the frequencies given here. Now I think we can perform chi-square test. So we'll go to the analyze. We'll go to the non-parametric tests. We'll go to the legacy dialogues and we'll go to the chi-square. Click on this. You can reset this and then you can shift your color variable into the test variable list and you need to press on OK only. So I hope I can press OK.
Yes, ma'am.
So you can see we are looking or we are getting the same results, right? The previous results
Sorry, can you repeat?
from where, ma'am?
When I click the chi-square test, the dialog box, I mean, what I have to do after clicking on that chi-square test?
Okay, you have reached to this.
Yes.
Here you need to only shift the color variable. You can reset. Once you will reset, everything will be the new for you. You can shift the color variable from the left box to the right box. And okay.
Okay. But ma'am, here I can see color 1 and color only
Color one,
colors.
I think, ma'am, we have already performed. You have seen here, I have shown you the data. I
Okay,
told
yes.
color one was the different, right?
Yes,
Here we are
yes,
having the individual variables, values.
yes. Yeah,
Then so we'll
yeah,
go with the color this time.
yes,
Fine. Clear?
yes,
Got the same output?
yeah.
Okay, but I think I forgot to tell you one thing because I think you should go both ways. Now go to again data, click on the weight cases and reset this. Fine. Again repeating, go to the data tab, select weight cases, reset the dialog box and click on OK. Is it fine?
Okay, ma'am.
Done. Now again you need to perform the chi-square test using the second variable, that is color variable. Now you see whether you are getting the results or not. So analyze, non-parametric test, legacy dialogs and chi-square. Here you can reset this. Then again I'm shifting the single, means color only, I'm shifting in the test variable box, clicking on OK, and you can see here you are not getting the chi-square value. It's coming as 0.000, whereas our chi-square value was 2.5. Is it clear?
Okay, ma'am.
So this is the meaning. If your data is in the frequency distribution form, you need to weigh your categories with the frequencies. Only then you should perform the chi-square goodness of it. I hope it is clear to all.
Yes, ma'am.
Yes,
Fine.
ma'am.
So expecting you now to open the second data set, the data set provided by me, named as Education Dog Honor. Opened, everyone? Once you people are ready, please let me know.
Yes, ma'am.
That. If you people are ready, shall I proceed? Everyone?
Yes.
Fine. You can find here there are multiple variables given in the sheet. Categorical, chi-square, second type of chi-square, that is independence of attributes, or test of association is looking for only the two variables. Yes? Yes or no?
Yes, ma'am.
So priorly I need to decide here which two variables I'm selecting. Suppose I'm selecting the gender and honor, pet honor, right? You can see here I have clicked on this data label icon. It is indicating me that is 2 was for female, 1 is for male, 0 is for no pet, 1 is for owns pet, right? Or if you wish, you can explore from the variable view also. Up to you which way you want to explore, right? Now, I want to see here there are two variables, gender and the pet ownership. I want to see whether there is any association between these two or not. So if you wish, you can note down the hypothesis. Hypothesis will be pet ownership is independent of gender. Pet ownership is independent of gender. Done? Pet ownership is independent of gender. It is done.
Yes, ma'am.
Or second form or second way of formulating the hypothesis will be there is no association between pet ownership and gender. There is no association between pet ownership and gender. Done?
Yes,
There's,
ma'am.
Wait, ma'am.
yeah, there is no association between pet ownership and gender.
Yes, ma'am.
Fine. So when hypotheses are clear, we can say now we will go for, because we are having two categorical variable, we want to find the association between them. We'll go for the chi-square test. So go to the analyze, then descriptive statistics and cross steps. Analyze, descriptive statistics and cross steps. Done? Dialog box has appeared.
Yes.
Shift your one variable into the rows, second variable into the columns. Shifting done?
Ma'am,
Yes,
can
ma'am.
we click it again, ma'am, from the beginning?
Okay.
Yes, ma'am.
Go to the analyze, descriptive statistics and cross steps. Done?
Yes, ma'am.
Now shift gender into the rows, pet owner into the columns.
Yes, ma'am.
Now you need to click on the statistics. Here select the chi-square, extreme left upper side. Click on continue. Click on cells and select the expected as well. Only observed checkbox is selected. Select the expected checkbox also. And then click on continue. Fine. May I go ahead?
Yes, ma'am.
Yes, ma'am.
I think it is enough to get the output. Click on the OK. Done?
Yes, ma'am.
Now, you can see I'm starting with the first table, which is known as case processing summary. This is telling us we are having total 20 count or 20 observations, right? For the pet and ownership combination. Then there is no missing value. Second table says, here you need to see, this is the table which is explaining you or giving you observed count and expected count. So you can see gender, male and female, right? For male, no pet means how many of the males are not owning the pet? 5 out of 10. Similarly, 5 are owning the pet out of 10. Female, 8 are owning the pet out of 10, and 8 are not owning the pet, and 2 are owning the pet. Is it clear? And then you can also observe here that we are having the expected count also. So as we are having 4 observed frequencies, we are having 4 observed frequencies, we are having 4 expected counts. Is it clear?
Yes, ma'am. This is the one you said the sum total will always come to 10, ma'am.
Not
Or
10.
no.
20% I told
No.
thing, right? You can see that thing, that assumption you can check here in this last
Total.
report, right?
Yes, ma'am. Yes. Thank
Yeah.
you.
Here, before reporting your output, you need to go at the bottom. You can find there are footnotes written which are saying 2 cells, that is 50%, because we are having total 4 observed frequencies. So out of as 4 observed frequencies, so I will be having 4 expected. Out of 4, 2 cells of the expected frequencies are less than 5, which you can observe here. It is 6.5, it is greater than 5, 3.5 less than 5, 6.5 is greater than 5, but 3.5 is less than 5. Means out of 4, 2 cells are having expected count less than 5. So in percent term, it is 50%, right? So it is violating the results, because up to 20% you will okay with, right? And you can go and you can report the CASCOR test. But when this percent is exceeding to 20%, we should not report the CASCOR test. And in such case, the suggestive test report which you need to report is Fisher's exact test, right? So in this case, you can come and see the significant value of Fisher's exact test is 0.350 for the two-tailed test, right? Which is greater than 0.05, meaning is that you are going to accept the null hypothesis. You will not reject your null hypothesis. And our null hypothesis says that pet ownership is independent of gender. That means there is no association between pet ownership and gender. That means there is nothing to do with the gender for deciding the pet ownership. Is it clear?
Yes, ma'am.
To all?
Yes, ma'am.
Fine. So now I wish, or I want, if you can perform the CASCOR, second kind of CASCOR test on the last 2 columns, that is pet owner and the education. Please perform and tell me what output you are getting. I hope you people are performing. Performing? Yes. Yes, are you performing?
Yes, ma'am.
Fine. Thank you, Monica ma'am. Anyone who got the answer? Output?
Ma'am, in my output, Fisher value is not showing, ma'am.
Yeah, that is why I told you people to perform. Yeah.
Yes.
So I'll perform, you see. Go to the analyze, right? I think you people have performed the same steps, so I'm not repeating. Coming here. Fine. Till here it is fine. Fine. May I go ahead?
Yes, ma'am.
This time, what you need to do, you need to go to the exact button and you need to click on the exact. Why so? Because now our table is not a 2 by 2 table. 2 by 2 table meaning is what? In both the variables, I'm not having only two categories. Out of these two variables, one variable, that is education variable, is having 3 categories that you can check in the variable. So when the table is not 2 by 2 table, in that case, you need to perform the exact, or you want to get the Fisher's exact test. If you wish, you will need to go to the exact and click on this exact. Is it clear?
Yes, ma'am. Yes, ma'am.
Yes.
And then you can click on OK. And I hope you can find here now the Fisher's exact test value, right? You perform and tell me, are you getting it or not?
Yes, ma'am. Now getting.
Fine. What about others? Is it clear now?
Yes, ma'am.
Okay, so anyone who can interpret the output and tell me what you can interpret from the results? Anyone?
P-value is showing, which is greater than 0.05.
So what we can say?
Our null hypothesis is accepted.
Okay, and what was that?
It was that there is no
Hmm?
1 minute, ma'am.
No issues.
It says that pet ownership is independent on
Independent of education level.
education. Yes, ma'am.
Yeah, very good. Means there is no association between pet ownership and education. Means education is not playing any role in deciding whether the person is owner of a pet or not. Is it clear? I hope you understood the application of this, right?
Yes, ma'am.
Fine. Okay, so now I will summarize the session of the day, and then if you're having any queries, I'll take that, right? So, friends, I started the session with the concept of non-parametric test. We discussed what is non-parametric test, and then I tried to link you with that particular thing, and then I talked about the chi-square test. We have understood the concept of chi-square test, and then we have seen the types of chi-square test, that is goodness of fit and the independence of attributes. Other name for the same is test of association, right? Then we have understood what kind of variables are required. Instead of having the mean, etc., we need to have the count of the data because we are dealing with the nominal and ordinal data here, right? And then I tried to explain you the concept of contingency table, how to formulate the hypothesis in both the cases, goodness of fit, as well as in case of the test of association. And then using the SPSS, we have seen how to perform both type of tests. The important thing when we talked about the SPSS, I told you that the data form is very important in case of goodness of fit, that whether you are having the individual values available or whether you are having the data in the form of frequency distribution, right? So that way you need to see this, and if the data is in the form of frequency distribution, you need to weigh your categories with the frequencies. And in that case, you can perform chi-square test, goodness of fit, very easily. Right. So I think this was the crisp or the summary of this entire session today. Now, if you're having any queries are most welcome. Please ask. No queries?
No question from my side, ma'am.
Okay. Thank you so much, Monica, ma'am. Okay. So if no queries, we will end today's session, right? And tomorrow I'll start with the parametric tests. Is it fine?
Yes, ma'am. Thank you.
Yes, ma'am. Thank you, ma'am.
Thank you so much, ma'am. Thank you, everyone. Good night. We are meeting tomorrow. Yoga sir, are you there? Yoga sir, are you there? Sir, we are done for the day. You can close the meeting. Yes. Thank you so much, sir.